Hey guys, today we are going to start talking about ionic bonding as well as naming of ionic compounds. So, starting it off, remember that positive and negative ions, they form in order to become more stable. When you have a positive ion or cation, like sodium here, uh, the positive charge would be attracted to an opposite charge, the negative here in this case, fluoride. So an attraction exists between the two. They're going to be drawn together. And again, as they come together, they're going to become even more stable as a molecule, as a collection. So what we see on a large scale as these things come together is known as the crystal lattice. It's an organization of positive to negative to positive to negative, this alternating pattern of these ions with charge. So this would be an example again of that structure. Notice the alternating positive, negative, positive, negative. The attractions that exist are so strong between a completely positive and completely negative thing that we find that salts and all different chemicals that are made up of ionic bonds, they tend to be solid under most conditions because they have very, very high melting points and very, very high boiling points. Once again, the idea here is that the attractions are incredibly strong between positive and negative ions. Let's talk about how we can manipulate compounds based upon the charges that we see. One thing that we notice that in nature is anytime we have a pairing of positive and negative ions, they always come together in a fixed neutral overall charge. So if we look at magnesium, for example, we'll notice that it has a +2 charge. Sulfide over here has a -2 charge. So if I were to consider my +2 combined with a -2, we find that there is 0 net charge. And the whole idea there is it's a stable compound when my ratio of magnesium ion to sulfide is in a 1-to-1 ratio. +2 with a -2 cancels out. Now sometimes we don't have this fixed easy 1-to-1 ratio. If we take our magnesium again, this time around, we'll take a look at what happens if a fluoride ion is introduced. Now, notice that a 2 plus and a 1 minus will not cancel out. +2 and a -1 ends up leaving us with a +1 overall. So in order to fix that, in order to make it a balanced net charge, what we'll do is we'll introduce a second fluoride ion. Now, +2, -1, and another -1 are going to have a net charge of 0. So once we've figured out this ratio, this comparison, you have a good idea that all of these compounds need to be neutral in terms of their charge. Let's talk about the way that we're going to write these out as chemical formulas. Our magnesium with its 2 plus and sulfide with its 2 plus can just be written out exactly as we see here, MgS. Notice that you don't need to write in the charges because the charges will cancel out. If you saw a charge value above, that means that we don't have a neutral compound. In that case, we would refer to it as a polyatomic ion, something that is not balanced and not neutral. When we look at more than one, like if it's not a 1-to-1 ratio again, you look at more than one ion that has to come together, we'll have to include subscripts after that element to indicate the number of ions present. So before we looked at this, you've got your magnesium, fluoride, and another fluoride. But we can simplify these two fluorides as a structure by putting a subscript of 2 in. So once again, this is just the shorthand notation that we use to indicate there is a single magnesium and there are 2 fluoride ions making the compound. Coefficients. A coefficient, if you recall, is a number that goes in front of some kind of a variable or chemical, and it indicates that you have more than one of that thing. If I'm going to try to put this together in a more simplified way, instead of writing magnesium and fluoride again, you can show that there are 2 fluorides by adding that coefficient. So important that we get this idea, that we understand when it's appropriate to use subscripts in a combined formula, or when it's appropriate to use a coefficient to indicate there's more than one individual species. Now, there's a method that we can use to help us as we're trying to figure out chemical formulas. Take a look at this pairing. We have aluminum, which is given as a 3+ charge, and we have oxide, which has given 2- charge. The goal is to determine, well, when these come together, what is the balanced chemical formula going to be? What we're going to do is we're going to go ahead and look at this 3+ charge. Well, since it's a 3 with a 2, the lowest common multiple or LCM that I'm going to use here is going to be 3 times 2. 3 times 2 gives 6. So we're going to need to get 6 positive charges and 6 negative charges. If I carry this 3 down as a coefficient on oxide, you'll notice that we now have 3 times 2, giving us a 6 in terms of the negative charges, right? 6 negatives. On the other end, if I look at the charge of oxide, the 2 value, make that a coefficient on the opposite ion, you'll see that we now have 2 times 3 makes 6 positive charges. Since the goal is we have to have neutral molecules coming together, 6 positive charge with 6 negative charge adds up to 0. So I now have a balanced chemical equation. Once I have the 2 and the 3, though, again, this isn't a chemical formula. This is what I need to make this compound, a single formula unit of this compound. So we're going to rewrite those as subscripts of 2 and 3 with no spacing in order to show the aluminum oxide that results. So now I want to give you an opportunity to do a little bit of practice. First off, look at the combination of these 2 ions, calcium and chloride. I'll give you a second to go ahead and respond to this, and then we'll move on. Your second question, what compound will be formed when the following ions bond? We're looking now at potassium ion and the phosphide ion. So take a second now. Question 3, what compound is formed when iron 3 combines with oxide? Now, what we're going to do is we're going to take these chemical formulas that we've seen and we're going to translate these into a word form. So we want to name our compounds. We're going to begin right here. Notice that you have the first ion is always the positive. Recall that we call that the cation, the positive ion. And the name on that positive ion would be magnesium ion. So we're going to write in magnesium as a starting point. We're going to leave off the word ion because that will be implied when we give the second word in its name. Now we have the sulfur atom, which is an ion. Once again, it is a negative ion whenever it's paired up with a positive cation. So we have anion with a cation. The name of the sulfur ion is sulfide. So when I name this, I'm going to call this compound magnesium sulfide. Our next example here, notice that we have aluminum, the metal, which means it will be the cation. We have fluorine, our nonmetal, which again means it's going to be the anion. And in this case, notice that you have a subscript of 3. Don't let that distract you. When we're talking about these simple ionic compounds that come together, a simple compound, we're going to once again just take the name of the cation, aluminum, combine it with the name of the anion, fluoride. So it should be pretty straightforward. If we get the idea here, just name the positive thing first, no modifications. Name the second as its ion form. So name the positive ion, name the negative ion, and you have your compound. So we'll practice some of these as well. First off, what is the name of the salt AgCl? Take a second now. Here are some options. Give that one a try. What is the name of the salt? BaO. What about our salt? Al2S3. Now, if you've been given a name, you're going to need to translate the name into a compound formula sometimes. You're not always going to be given the symbol form of an ion. You might get a name instead. So what we have to do first is we have to do a couple things. We've got to identify, are these ions cations or anions, or did they come from metals or nonmetals? Once I do that, then I've got to look at what group they're found in to find the number of valence electrons. Now, the first name that we're going to use here is sodium. And what I want you to think about is this. Sodium has the element symbol Na. It is a metal, which means that it's going to be a positive ion. Now, this positive ion is in group 1. So if it's in group 1A, that means it has 1 valence electron, and the charge of sodium is 1+. Next, we're going to look here at phosphide. Well, our phosphide comes from the phosphorus atom. Recall that our phosphorus is a nonmetal. So this nonmetal, if I want to figure out what charge it's going to have, I've got to consider its group. We find phosphorus in group 5A. So unlike our cation, our metal ion, you don't just look at the group and, oh, well, it's a 5. It's going to be a 5 charge. We got to consider that to go from group 5 to get into 8, I need to gain 3 electrons. So that means the charge on our phosphide is 3-. So we take these two ions with charge, our sodium ion and our phosphide ion, and now we're going to go ahead and look at the charge, see the ratio of charges. Do they cancel out? A 1+ and a 3-, positive 1, negative 3, not 0, right? I end up with -2 overall, so they're not going to go together in a 1-to-1 ratio. What we'll do is apply our cross balancing. Take your 3 on the phosphide and write that as a coefficient on the opposite thing, the sodium. Then we take our 1 from the charge of sodium and we'll apply that as a coefficient on phosphide. Here it's implied, we don't have to write a 1. So now that I have it in this form, when these come together, they're going to form sodium with 3 ions, phosphide with 1 ion. Rewrite those coefficients as subscripts. So what that will be Na3P in its chemical form. Practice this as well. First off, what is the chemical formula for potassium iodide? What is the chemical formula for beryllium oxide? What is our chemical formula for strontium bromide? And finally, what is the chemical formula for calcium nitride? Hopefully this was helpful, guys. These concepts, they're going to carry forward for a very long time. So if you have additional questions, please don't hesitate to ask.